We spent 10,000 years trying to conquer nature. We paved it, fenced it, and poisoned it. We thought we won. But in 2026, we're realizing a terrifying and beautiful truth: nature wasn't defeated. It was just waiting. Today, we aren't talking about planting trees or saving the whales. We're talking about the Great Restoration, a high-stakes, multi-trillion-dollar engineering project to climate-proof the planet by letting the wild take back what's ours. Chapter 1. The Forbidden Zones. Nature's lab. To see the future of a climate-proof world, we have to look at the places where humans are strictly forbidden. Take the Chernobyl exclusion zone. For 40 years, humans have been largely absent. The result? It's not a wasteland. It's a thriving, radioactive Eden. Wolves, lynx, and the rare Przewalski horse have reclaimed the streets. But here is the FactsTube twist. These animals aren't just surviving, they're adapting. Scientists recently discovered that the frogs in Chernobyl have evolved higher levels of melanin, turning them pitch black, to protect themselves from radiation. This is evolution on fast forward. When we step away, nature fixes itself with a speed that defies our climate models. These forbidden zones are proving that the most effective way to sequester carbon isn't a high-tech machine. It's a self-regulating, apex predator-heavy ecosystem. Chapter 2. The Math of the Forest, CO2 versus the machine, and the tech world. We're obsessed with direct air capture, DAC. We're building billion-dollar fans to suck carbon out of the sky. But let's look at the thermal dynamics. A single mature tree can absorb approximately 22 kilograms of CO2 per year. That doesn't sound like much until you scale it. The Earth currently has about 3 trillion trees. If we hit the Great Restoration target of planting, or naturally regenerating, another 1 trillion, we could theoretically offset a decade's worth of global emissions. Photosynthesis is the most efficient carbon sequestering technology in the known universe. And unlike our machines, it doesn't require a power plant to run. It is the power plant. Chapter 3. The Ghost Cities. Nature reclaims the concrete. There's a viral aesthetic called life after people. But in 2026, it's not just a TV show. It's a policy. Under the new EU Nature Restoration Law, countries are now legally mandated to restore 20% of their land and sea areas by 2030. This means unpaving the world. In cities like Berlin and Tokyo, microforests, the size of a tennis court, are being planted in the middle of concrete jungles. These aren't parks. They are climate-proofing shields. A microforest can drop the local temperature by up to 10 ring operator C. In a world of record-breaking heat waves, these green anchors are the difference between a livable city and a lethal one. Chapter 4. The Biohacking of the Wild, the Risky Frontier. Now, let's get into the FactsTube edge. To truly climate-proof the landscape, some scientists say we need to bring back the engineers of the past. Enter De-extinction. Companies like Colossal Biosciences are using CRISPR to bring back the functional equivalent of the woolly mammoth. Why? Because mammoths were the landscapers of the Arctic. By stomping down the snow and knocking over trees, they kept the permafrost cold. It sounds like Jurassic Park, but it's actually a high-stakes climate hack. If we can re-engineer the Pleistocene steppe, we might be able to lock down the billions of tons of methane trapped in the Siberian ice. It's the ultimate restoration, bringing back the dead to save the living. Chapter 5. The Deep Sea, the blue carbon mystery. We talk about the green restoration, but the real battle for the planet's temperature is being fought in the blue. The ocean is the world's largest carbon sink, absorbing nearly 30% of all human-generated CO2. But here's the problem. We've treated the seafloor like a silent graveyard. In 2026, that graveyard is waking up. Scientists are now identifying blue carbon as our secret weapon. A single hectare of mangroves can store up to 10 times more carbon than a tropical rainforest. But the real high-stakes drama? The great whale. When a whale dies, its body sinks to the bottom, sequestering an average of 33 tons of CO2 for centuries. By restoring whale populations to pre-whaling levels, we aren't just saving the animals, we're building a biological carbon storage fleet. But in 2026, this restoration is under threat from deep-sea mining companies eyeing the polymetallic nodules on the seafloor. It's a race. Do we mine the bottom for battery minerals, or do we leave the blue carbon locked in the abyss? Chapter 6. The fungus among us. The wood wide web. If the trees are the lungs of the Great Restoration, the fungi are the nervous system. Deep beneath the topsoil lies the mycelium network, or what scientists call the wood wide web. This isn't just a metaphor. Fungi are the ultimate carbon brokers. They trade phosphorus and nitrogen to trees in exchange for sugar. In the process, they lock massive amounts of carbon into the soil in a stable form called glomalin. Here's the FactsTube shocker. 70% of all carbon stored in the soil is managed by these fungal networks. The Great Restoration isn't about planting trees in rows, it's about inoculating the soil with the right fungal spores. If we destroy the mycelium through industrial tilling, the trees we plant will starve. To save the sky, we have to respect the rot. Chapter 7. The Vertical Revolution. Living skyscrapers. By 2050, 70% of humanity will live in cities. If we don't bring the restoration to the skyline, we fail. Welcome to the vertical revolution. These aren't just pretty buildings. Architects in 2026 are using biophotovoltaics, integrating algae and moss directly into the glass and steel. These buildings don't just use energy, they produce it through photosynthesis. A single forest tower can filter over 30 tons of dust and smog from the city air every year. This is the end of the concrete oven. By turning our skyscrapers into vertical ecosystems, we aren't just cooling the streets, we're creating sky corridors for migratory birds and pollinators, effectively extending the Great Restoration into the clouds. Chapter 8. The Great Migration, Assisted Evolution. This is the most controversial chapter of the restoration. Usually, we think of nature as something that stays put. But the climate is moving faster than the roots can grow. Enter assisted migration. Biologists are now playing God by manually moving entire species of trees and plants hundreds of miles north to where the climate will be in 50 years. Critics call it ecological roulette. They worry we are introducing invasive species into new territories. But the restorers argue we have no choice. If we don't move the forests, they will simply die where they stand. It's a high-stakes gamble. Do we let nature take its course and face mass extinction, or do we become the architects of a new, synthetic wilderness? Chapter 9. Sponge cities, swallowing the hurricane. Finally, we have to talk about the water. Our cities were designed to shed water, to push it into pipes and out to sea. In a world of superstorms, that design is a death sentence. Welcome to the Sponge City. Pioneered in China and now a global standard in 2026, this restoration involves ripping up the asphalt and replacing it with thirsty landscapes. These cities don't fight the flood, they inhale it. By restoring the natural floodplains inside our urban centers, we're doing more than preventing damage. We're recharging our groundwater and creating urban oases that stay green even during droughts. It's the ultimate climate-proof landscape, one that views a hurricane not as a disaster, but as a resource. Conclusion. The New Eden. The Great Restoration isn't a dream of the past. It's a blueprint for the future. It's the realization that the most advanced technology on this planet isn't made of silicon and code, it's made of carbon and DNA. We are no longer just the destroyers of this world. We are becoming its gardeners. The question isn't whether nature can survive us. The question is, are we brave enough to let it take the lead? Because in the end, a climate-proof, world isn't one where we control the weather. It's a world where we finally learned how to live within it. Make sure to follow for more upcoming documentaries that will enhance your knowledge.